So a girl, please tell me what you got for expression A when you plugged in 5. Go ahead, Jordan. 8. Did anyone get something other than 8, ladies? Yes? 3. Any other answers other than that? So we'll see what's right in a minute. Boys, when you plugged in 5 to expression B, what did we get? Any other answers other than 8? So you either got nothing at all or you all got 8, is what you're saying. Okay. All right, now girls, when you plugged in 7, what did you get for expression A? You can call it out. 20, anything other than 20? All right, boys, when you plugged in 7 to expression B, what did you get? Anything other than 20? Girls, when you plugged in -1 to expression A, what did we get? I heard a 4. Okay, anything other than -4? Yes. -5. Anything else? All right, boys, when you plugged -1 into expression B, what did you get? Anything other than -4 out there for boys? All right, now girls, when you plugged in 13, what did you get? 80, anything other than 80? Boys, when you plugged in 13 to expression B, what did you get? Did I hear you right? Anything other than 80 for the boys? Now, what are we noticing between our answers? And there were some that we got like a variety of answers. So we'll see why those mistakes were made in a second. But it should be that even though we have different looking expressions between the girls and the boys, you each would have had the same answer. Okay, so it is 8 for expression A, and it is -4 for expression A when you plug in the -1. Okay, but I imagine there was a lot of people that had blanks that didn't have enough time, that maybe if they did have enough time, they could figure it out. But like I said, unless you're using a calculator, then you really would have to know your order of operations. And that's not something we do a whole lot of examples of in here. Like that was a previous grade skill that you learned when you did order of operations. So just like if you still don't know your times tables, at this level, we just give you a calculator. Just like if you are bad at adding positive and negative numbers, at this level, we give you a calculator. You just have to know how to use it. So here's how. You could type these in and get the answers within that 3-minute time frame, I believe. Anytime that you're plugging something in for a variable, what do I tell you to use? Parentheses. So like for expression A, if I was plugging in a 5, this might be how it looks on my paper. That's what I mean by like whenever you plug stuff in, use parentheses. Sometimes it makes a difference, sometimes it doesn't. But you can see like, especially when we plug in negative, it will make a difference. So that's why you should just do it every time for good practice. Desmos is really user friendly. If you're using like a handheld calculator, you'll probably have to put parentheses around your numerator and denominator. Like this. So that it reads it right. But it is still possible. It's like and then down here it's 2 parentheses 4 - 3. If you're using like a handheld calculator, you might have to put your denominator in parentheses as well. But you could see my answer is 8 for the girl expression. I'm gonna clean it up a little bit. But now that I have it typed up in there, and I did use parentheses in order to plug in my variable, then all I now have to do is change what's in the parentheses. So like the next number I plugged in was 7. So it is 20. The next number I plugged in is -1. See what happens when you don't put that parenthesis around it. That's where we got the -5 from. Okay, that's why it's important. Anytime you plug stuff in, use parentheses so you get the right answer. And then the last one we plugged in was 13, and that's where I get the 80. Okay, so easy. All you have to know is how to type it in, and then you can get all your answers. Questions on that? All right, and then here's for the boys, just to show you it does still work. It just might be a little harder to type it in. Anytime you plug stuff in, use parentheses because sometimes it does make a difference. And I'm typing it in like I would if it was a traditional calculator. So, sorry, it like doesn't want me to, I'll just start over. Okay. 5 minus 3. Okay, over 8 minus 3 times 2. Okay, so exactly what I had on my paper, except for that anywhere that there was a variable, we're putting parentheses and we're putting the number that they wanted us to substitute in for it. So when I plug in 5 in both spots for n in the boy expression, you do get 8. When I plug in 7 for both spots in the boy expression, you do get 20. When I plug in -1 for both spots, you do get -4. And when you plug in 13 into both locations for the n, you do get 80. So it's all about, at this level, knowing how to type it in to get your answers quickly when all we're doing is substituting in a number. Questions, comments, concerns? So then that wasn't like the main objective of this warm-up, to review that, even though it is an important skill, knowing how to use your calculator. The main objective is to see, what does it mean when I have the same input and output pairs in both expressions? So if I can plug in the same number into both expressions and get the same answer, what does that mean about these two expressions? They are equivalent. Oh, that is it. So in that space where you do have some room, it's not a lot of room. But for the warm-up, if you have room still, write something about equivalent expressions. When you plug in the same value and get the same answer multiple times, they're probably equivalent expressions. So you could say equivalent expressions give the same table of values. Which table of values is something we talked about last week. So like for expression A, here would be like what I plugged into it. This would be my input. And then when I plugged it in and simplified, these were my outputs. And then the same exact thing happened for the boy expression. I plugged in the same inputs and got the same exact output. What do you usually do with these input-output pairs? Where can we put them? Maybe we're not there yet, but you'll see later how to also count their equivalent other than having the same table of values. Okay, but great. That is our lesson today. Like, I mean, that's not the whole lesson, but our lesson is about equivalent equations. So now we're going to add an equal sign, make it an equation, but the premise is still the same. If I can plug in the same inputs and get the same outputs, even though they look a little different, These are the same. I'm gonna pull up the learning targets. I see some people are writing, so I'll just read them from that back whiteboard over there. They're also at the top of your paper too. But by the end of the lesson, you need to be able to tell whether two expressions are equivalent and why. So you could say, they give me the same table of values. And I plug in 5, I get 8 for both of them, something to that effect. You also need to be able to identify the moves that can be made to transform an equation into an equivalent one. This one's actually pretty hard to figure out what I could do to this one to make it that one. But the other ones will be easier. And when we say moves, it's like steps. Like what can I do to both sides of the equal sign to make it into another equation that is so good. And then be able to understand what it means for two equations to be equivalent and how they can be used to describe the same situation in different ways. I'm recording right now. As you know, I do that every day, usually in this class. So if you ever miss anything, whether you're absent, whether you're in the bathroom, whether you just weren't paying attention, it's there. You can go back and relearn it anytime. Puzzle piece is lesson 6, or it's not a puzzle piece anymore, I guess. It's like a purple checklist. But anyway, lesson 6 is what we're doing right now. And your next quiz will be Thursday over lessons 5 through 9. So quizzes, again, are little checkpoints mostly for you. The last quiz you took on Friday, you can view and see how you did and ask questions about it. Or do corrections for half credit back. Whatever you want, but like, I make it viewable so that you can learn and grow. And that goes in the assessment category, but it's only 10 points. So it's just for you to see how you're doing before you get our unit test later this month. Any questions? Okay, so back to the activities. And I can't stress this enough. I feel like people see words and they just want to like skip them. But it's a word problem. It's actually really not that hard, I promise. Give it your best shot. You're gonna write as many equations as possible that could represent the relationship between the ages of two children in each family as described. Be prepared to explain what each part of your equation represents. So family A, the youngest child is 7 years younger than the oldest, who is 18. There's lots of ways to represent that. That's why it says write as many equations as possible. Stop talking. In family B, the middle child is 5 years older than the youngest child. There's many different equations you can make. That's why it says write as many as possible. Start with one and see what you can do to make it another one that says the same thing. I'm gonna give you 3 minutes to do that. Okay, and normally I do a really good job of holding you all accountable and assigning reporters, but it's Monday and we need to just get a move on. Cross off as many learning targets as we can. So I'll take a hand raise for who thinks they have an equation for family A, where the youngest child is 7 years younger than the oldest, who is 18. So long as it has an equal sign and makes sense for the situation, or is more than one answer, wait. Brayden? Equals what? Okay. Jordan? All right, any others out there? Let's evaluate and make sure these make sense. So could you actually tell me the age of the youngest child? What is the age of the youngest child? They do give you enough information for that, right? Because If they're 7 years younger than someone who's 18, then they're 11. Okay, so let's see if your equations make sense. So is 11 plus 7 18? So then this one can work. Good job, Blaze. Is 11 minus 7, or sorry, let me re-say that. Is 18 minus 7 11? Okay, great. They just used n. It didn't really specify that they had to use a certain variable. So sure, you can use n. If you tell me that n is for the youngest child's age, then that works. Does this one work as well? Yeah, 18 minus 7 is 11. So all of these do make sense. Good job. There are others you could have. And here's where we get into that second learning target about the moves that you can make to see if one equation is equivalent to the other. So say that I didn't have this in my head, say I only had that one. But I wanted to see if your guys' was true. I can manipulate this one to get the y alone like how it is over here. What would I have to do to the 7 in order to make that happen? Subtract it. And whatever you do on one side of the equal sign, that gets the y alone. And really you could simplify this, 18 minus 7 is 11, or you could just rewrite it next to each other. So this confirms, other than knowing it makes sense, this confirms that they're equivalent. Now, what if I wanted, say, the 7 to be alone on one side? Because it doesn't, you'll see it doesn't really matter what's alone on one side. You can make other equations, so long as whatever you do to one side, you do to the other. So say instead, I want the 7 to be alone. I'll manipulate this one because it'll be easier. If I want the 7 to be alone, I would have to get rid of the y. How could I make the y cancel? Subtract y, whatever you do on one side of the equal sign. So then that would cancel out the y, so 7 is now alone. I don't technically need to write plus 7 if it's positive, it's implied. There's no sign there, but it's positive. And on the right-hand side, I could just write 18 minus y, and here's another equation that's equivalent. Right? Doesn't it still represent the situation? 18 minus the youngest child's age is 7. That makes sense. Okay? So good. Questions on that so far? So now let's evaluate family B. Who thinks they have a good equation for family B? Right here, table 5. X minus 5 is what? Okay, and what is X representing? Oh, okay, middle child is what you're sticking with? Okay. So let's see if that's true. In this one, it says the middle child is 5 years older than the youngest child. So my brain would automatically go to the middle child age. 5 years older, that would be more than, so like plus 5, than the youngest child. So are these two equivalent? No. Did I hear you wrong? Or okay. So let's adjust it to this, because let's make up an age for the youngest child. Let's say the youngest child is 1. How old would the middle child be then? If I put a 1 here plus 5, that would give me 6. Oh wait, is that backwards? Yeah, it is backwards. Maybe Julia was right to begin with. Because if I'm saying the middle child is 6, then yeah, she was right to begin with. Sorry guys. You have to like go through that process and really think about it. So yeah, she was right to begin with. My apologies. So we've confirmed this one is right, because now I'm giving you an example. Say the youngest child is 1. How old must the middle child be? And this makes sense, right? You just kind of have to test it out and see if it makes sense. And then you can see what other variations we can have. So I know some of you had your hands up, great. I think the process I'm gonna go through will confirm if yours is right, and then if not, then we'll see. I'm also gonna change this to be letters that make more sense to me. I'm gonna make the middle child M and the youngest child Y. You can use whatever variables you want, but I'm just gonna do that for my own brain. So I don't do this like I did already. Okay. Anyway, we confirm this one is correct. Let's say some of you have it where the middle child age is alone on one side. How can I make it to where the M is alone? What could I do to this? And whatever I do on one side of the equal sign. So that would cancel the 5 and isolate the M. And on the right-hand side, I could just rewrite it as Y plus 5. I can't actually simplify it because I don't know what either of those are, but you can just rewrite it. Those are our literal equations. When there's more than one variable, you can't simplify, you can just rewrite. So here's another answer you could have had. That is also right. The youngest child plus 5 age is the middle child's age. So we have where the Y is alone, we have where the M is alone. Let's put it where the 5 is alone. I would have to subtract Y if I want the 5 to be alone. Because I have to think what makes it cancel. Well, subtracting it would. That would cancel it here. What would I have on the left side? M minus Y. I don't know if that's what you said, but that's what I hope you said. Because that would be right, yes. And then on the right side would just be 5. So I think that covers every variation other than like 5 plus Y is also M. Are there any that you'd like to share that you want to see if are also right? And this one I isolated each part. So order matters in subtraction. It'd have to be M minus 5 or M minus Y. You can't switch those. But order doesn't matter in addition. So you can do 5 plus Y. Okay, good. Any questions? All right. And we will probably still do the other activities tomorrow because they are really valuable activities. We just don't have time today. So don't lose your paper. You have a whole 2 minutes to put it away properly. And don't lose it because you definitely are going to need it tomorrow. We're also doing lesson 7 tomorrow, so just make sure you're ready.